In this video, I'm going to solve a programming problem using a loop. This particular problem is kind of math-based, and sometimes students are intimidated by problems that appear to look like math problems in disguise. But this one is pretty straightforward. It says that we're going to count from 1 to 50 and add up a sum as we go. We're going to calculate the sum of every integer from 1 to 50. So a pretty straightforward problem. In fact, you're probably going to find that that the solution to this is maybe a little easier than you thought once you really get in and try it. So as usual, I'm going to suggest that you stop here and give this problem a shot on your own, and then play through the video and see what my solution looks like and compare it to yours, or use it for help on anything you got stuck on. So go ahead and pause the video, give it a shot, and then hit play when you're ready to start. Okay, so this algorithm, if you will, is going to really just have one outcome. There's only one answer, one output that this is going to produce when it is run, assuming that we really run it from 1 to 50 every time. So it's going to say 1 and then 3, which is the sum of 1 and 2, and then 6 because we're going to add 3 onto it, and we're just going to keep adding on whatever number we start with. So again, it sounds maybe a little bit intimidating if you're not a math person, but if you think about it, it's pretty straightforward. And one of the things that I encourage people to do as they are approaching a problem, especially if the solution to it is not kind of obvious, is to get out a piece of paper and try it. Try writing the numbers from 1 to 50 and add them up, and kind of look at the process you go through to do that. So we'll go ahead and switch over to NetBeans here and begin to solve this. So I've already set up the class, and I've got a main method here waiting for us. And at the heart of this problem, of course, is a loop. And when we're going to create a loop, we have a couple decisions to make, or a couple different ways we can do this. And one of the things that I encourage students to look at is the basic structure that you're going to use to set up your loop. Because generally speaking, you can say that loops fall into two broad categories. There are loops where we know how many times they have to execute before they start executing. In other words, we know how many times we have to iterate. And then there are loops where we don't know how many times we're going to have to iterate. And a classic example of that latter kind is when you're prompting a user for a password, because we don't know how many times it's going to take them to enter the correct password, right? And so we're going to keep looping until they enter it correctly. And obviously we could have other stopping conditions, like a limit to how many times they can guess or whatever. But we call that an indefinite loop. We don't know how many times it's going to have to run. Now, when we talk about a definite loop, where we are defining ahead of time how many times it's going to iterate, I am including in that the idea that we may not know when we're typing the code how many times it's going to iterate. In other words, in this case, we know that it's going to go from 1 to 50. It's possible that we have a program where we're going to say, enter the maximum, type in the maximum, and the user can type in 50, or they could type in 100, or they could type in 1,000, or whatever. And so I don't know when I'm writing the code how many times it's going to execute at runtime, but when the program is executing, as the loop is starting, we know how many times it's going to have to run. So that's the kind of a problem that we're looking at here. Now, particularly when you're first starting out with loops, my philosophy is that pretty much anything you can do with a for loop, you could also do with a while loop. And I don't think there's anything inherently wrong with just taking the approach that I'm better at one or the other, and so I'm going to use that to solve my problem. I do think, of course, that you need to know how they both work, and you should be working towards being able to write loops well with either structure. And note that I'm counting a do-while loop kind of as a while loop for now. That's the same basic idea, right? That said, there is this general sense that if we have an indefinite loop, that's probably a good situation for a while or a do while structure. And if we do know ahead of time how many iterations we'll need, then that's probably a good use for a for loop. So this one I'm going to use a for loop, and as always, my suggestion is to work in very small steps. Write a little bit of code and run it and debug that code and then move on. So we're just going to start off with setting up the loop. So for loop, we're going to have to define these three parts, and by convention, many programmers will just define the variable I inside their for loop. And of course, we always want good descriptive variable names, and I is not a very good or descriptive variable name, but it is conventional. It's very typical to see loops, for loops set up with I as that counter. So I'm okay with that. In this particular case, notice that the problem refers to that number as n, and so for that reason, I'm just going to use n as my variable there. Obviously, it doesn't matter, but that's the way I'll set it up, just to match the text of the problem. And as I set this up, you're going to see that we're going to need to make some changes as we go. But we're just trying to get the basic. Remember, we're just throwing out the basic idea, and then we will refine it. In fact, we call that stepwise refinement, where we're just going to start with a solution, and we're going to keep improving it until it matches what we want. So we're going to start at 0, and we're going to go as long as n is less than 50, and in my opinion, that's going to give us 50 iterations of this loop. And I suppose the simplest thing to do is just output n and run this and see what we get. Oops. I need to save this and probably set up my profile. Okay, so I'll stretch this out so we can see what happened. And what we have is our output starts at 0 and it goes to 49. And now that's not exactly what we want, but it's a good start. And I would point out that we are iterating the correct number of times. We are going from 0 to 49, which gives us 50 trips through the loop, so to speak. And so that is definitely a good start. And in programming, we often, certainly not always, but we often are 0 based when we count. We start at 0 and we count up from there. And so we stop one less than what we might kind of expect from our daily lives, where we typically count starting with 1. And a big reason for that is when we get to arrays and other collections and those kinds of data structures, they are indexed starting at 0. And that's a statement that I just make that won't resonate with you right now, but there is a reason why we start with 0, and you'll see that reason a little bit later. So this is a good start. Now, what the problem is actually asking us to do is to not just output n, but to add n up as it goes. And so to do this, we're going to need a separate variable. N is going to be what essentially controls how many times the loop executes, and it also keeps track of kind of which number we are on. And I missed my train of thought there. What we need to do for this problem is we need it to go from 1 to 50 inclusive, so to speak. And so we don't want it to start at 0 and stop at 49. We want it to start at 1 and stop at 50. So I'm going to change that. And this may seem like an odd choice to you, but I prefer to write my Boolean logic that way, so that it says is less than 51. It is precisely the same thing as this, which may seem more clear to you, and either one is fine, but I'm in the habit of just going with less than. So 1 to 50 there. Let's run that and just make sure that yes, we're stopping at 50, and if I scroll up, yes, we started at 1. So okay, back to my original thought there. we're going to need a separate variable to keep track of this sum that we are trying to calculate. And so what we call that kind of a variable is an accumulator, right? It's going to accumulate a value as the loop runs. And so we'll need to set that up outside the loop. If I define any kind of a loop inside, if I define any kind of a variable inside the loop, the rules of scope apply, and that variable is going to get essentially thrown away at the end of each iteration. So I'm going to declare my variable up here. I'm going to call it sum, and I'm going to initialize it to 0. Accumulator, and I'm just going to identify that as an accumulator there. That's going to be what I use to kind of add up this answer that we're looking for. And so what I'm going to say, every time we increase n, we are just going to add this new value of n onto sum. And so the long-handed way of writing this is sum equals sum plus 1. Okay, what you will more typically see programmers do, if you're looking at code online, for example, is to write it this. Oops, and I put 1. I really meant to put n, so that we might as well use that variable that we've got, right? Sum plus equals n, and then I want to output sum here. Okay, and if I run this now, 1, the sum starts at 1, and then we say 1 plus 2 is 3, and then plus 3 is 6, and plus 4 is 10, and plus 5 is 15, and plus 6 is 21, and so on and so forth. If I really want to make this clear, I can do something, I can kind of label, so if it helps you to understand what we're looking at a little bit better, I can label it like that. And you can see what n is to the left of that colon, and then what our sum is to the right of the colon. And so it looks to me like this is doing what we're supposed to do. And this is essentially it for this problem. That is all that it's asking us to do. I do want to point out that this idea of an accumulator, this is really common in programming. This is a fairly common kind of algorithm. And especially when we start looking at like traversing arrays, I mentioned arrays a couple minutes ago. A lot of times we might have to run through a series of data and add them up, and for example, to calculate an average, we're going to get the sum and then divide it by the count. And so this is a fairly common algorithm. But what I'm going to do next is just for the benefit of people who are trying to learn both types, or if you happen to write yours the other way, I'm going to write the same loop using a while structure. I'm going to write the same code as a while loop. So what I'll do is just comment this out and run it just to show you that we haven't missed anything there with our commenting. And it's going to work in some ways the same way. Well, it is not in some ways. It's going to work exactly the same way. I'm still going to need n, and I'm going to initialize n to 1. And then I'm going to have my while loop that says while n is less than 51. See if I can rearrange my windows here so we can see a little better. While n is less than 51, and I can just steal this code here. Sorry. And now this is the, I was going to run it here to demonstrate the dreaded infinite loop, but I'm guessing by now you've probably already experienced that. If I just run the code like it is, n is equal to 1, and it's going to repeat forever, right? Because we never increment 1, or we never increment n, and so we can do that there. If I run it now, we should get our 1 to 50 output just like we had before. And same thing, I'm going to set up my accumulator. I'll just add it right below here, and sum equals 0. And again, this is the trademark laziness of programmers the world over, is why write the code when I can Copy and paste what I've already written. Okay, and so what you can see here, I'll scroll up to make sure you can see it all, is you can see the same algorithm written with a for loop and then again with a while loop. And as I mentioned at the start of this, either one is acceptable, either one works fine. My preference is to look at this kind of a loop as being a good fit for a for loop, but either one works fine. And that's all we got. Now this one is finished.